Think about the last project you managed. Did it feel like a smooth journey or a series of unexpected detours? Most project failures aren't due to a lack of effort, but a lack of structure. Welcome to our deep dive into the project lifecycle, the foundational framework that dictates how every project is born, grows, and eventually closes. In this session, we will explore the skeleton of a project, its phases, and the critical gates that keep it on track. More importantly, we'll discuss how to choose the right delivery approach to ensure success. Whether you are building a skyscraper or a mobile app, this framework is your universal guide. By the end of this module, you'll understand how to structure your work to survive shifting environments and demanding stakeholders. Let's start by defining our specific goals for today. What exactly should you walk away with today? We have 3 primary objectives. First, we will deconstruct the framework. This means moving beyond the buzzwords to understand the actual anatomy of life cycles, phases, and gates. Think of this as learning the rules of the road before you start driving. Second, we are going to differentiate between delivery approaches. You've likely heard of predictive and adaptive models, but we will master the full spectrum, including the increasingly popular hybrid models. Finally, for those preparing for certification, we will master the exam logic. We'll show you how to apply these concepts directly to those tricky situational PMP questions. This matters because knowing what a life cycle is won't help you unless you know how to use it when a project is failing. Let's look at why this is considered the engine of success. Why do we call the project life cycle the engine of success? Because it provides a universal application. It doesn't matter if you are in healthcare, tech, or construction. The fundamental need for structure is the same. This framework drives strategy by aligning your daily execution with high-level organizational goals and, crucially, your company's risk tolerance. For senior leaders, this is a tool for executive decision-making. It proves that as a project manager, you have the skills to tailor a delivery framework to a shifting environment rather than blindly following a template. Furthermore, this is a core PMP pillar. If you want to pass the exam, you must be able to navigate the scenarios that test your ability to pick the right cycle for the right situation. Now let's move from why it matters to what it actually is. So, how do we define the project life cycle? It is the complete series of phases a project passes through from initiation to definitive closure. While every project is unique, most follow a standard progression. You start the project, move into organizing and preparing, carry out the actual work, and finally, close it down. A critical point to remember is that the project life cycle functions independently of the product life cycle. For example, a project to build a bridge ends when the bridge is open, but the bridge's product life, maintenance, and use continues for decades. This framework is highly adaptable. You must shape it to fit your specific industry and organization. Think of it as a container that holds all your project activities. Let's explore that container concept further. Imagine the life cycle as a container. Within this container, we organize every activity and deliverable. It dictates what work is formally executed, who needs to be in the room, and what the final output looks like. This structure is what keeps a project from turning into a chaotic free-for-all. However, a good project manager knows that a container shouldn't be a cage. It requires active tailoring. You have to fit the life cycle to your project's unique constraints and risks. The goal is to provide enough governance and oversight to satisfy stakeholders without stifling the team's ongoing agility. To do this, we need to understand the building blocks of that container, the project phase. What exactly is a phase? It is a logical grouping of project activities that require a specific focus. For example, a design phase or a testing phase. Every phase is specifically designed to culminate in the completion of a tangible deliverable, something you can see, touch, or measure. To be effective, a phase must be clearly defined. It needs a distinct name, an expected duration, specific resource needs, and strict entry and exit criteria. You shouldn't move from phase A to phase B just because you feel finished. You move because you met the exit criteria. This approach fundamentally breaks massive, complex projects into manageable, measurable components. But how do we connect these components? There are 2 main ways. How you connect your phases depends on your project's need for speed versus need for safety. The sequential approach is the traditional method. Phase B begins only after Phase A is 100% finished. This profile is lower risk because you aren't guessing about the outcome of the previous phase, but it results in a much longer total schedule. Alternatively, we have the overlapping approach, also known as fast tracking. Here, Phase B initiates before Phase A concludes. This compresses the schedule rapidly, but it heavily increases the risk of rework. If you start building based on a design that isn't quite finished, you might have to tear it down if the final design changes. Choosing between these depends entirely on your organization's risk appetite. But how do we ensure we're making the right decisions at these transition points? We use phase gates. Phase gates are the quality control checkpoints of project management. These are formal management reviews placed at the end or beginning of a specific phase. You might hear them called stage gates, iteration reviews, or even the kill points. Their job is simple: to stop and compare current project performance against the original business case. It ensures the project is still perfectly aligned with the organization's strategic goals before leadership signs off on more investment. Think of it as a go/no-go decision point. If a project is no longer viable, the gate is where we stop the bleeding. Let's look at the specific outcomes that can happen at a gate. When you hit a phase gate, there are 4 possible outcomes. The ideal outcome is continue. Everything is on track, and you proceed as planned. Sometimes, however, you'll be told to modify. This means you can keep going, but only after making mandatory adjustments to your scope, budget, or timeline. In other cases, the project might be parked to address more urgent business needs. And then there is the terminate option, the kill point. This is where we permanently end a project that has lost its viability. A vital PMP exam tip to remember: gates exist specifically to prevent throwing good money at a failing project. By understanding these outcomes, we can better manage the variables that change over the project's life. This is a must-know concept for any project manager. If you look at this graph, you'll see that risk and uncertainty are at their absolute peak during initiation because so much is unknown. This is also when stakeholder influence is highest. They can change the whole project with a single meeting because nothing is set in stone yet. However, notice the cost of change curve. At the start, changes are cheap. But as you carry out the work and solidify the project, the cost of making a change spikes dramatically. Changing a blueprint is easy. Moving a foundation after the concrete is poured is incredibly expensive. This relationship is why our choice of development approach is so critical. Let's look at the spectrum of those approaches. How do we decide how to build our product? We look at the development approach spectrum. On one end, we have the predictive approach. This is plan-driven and sequential, focusing on getting everything right up front to ensure certainty. On the other end is the adaptive approach, also known as Agile. This is change-driven, utilizing short iterations to learn as we go. Most modern projects actually fall in the middle, the hybrid approach. This is a customized blend of methodologies. As a project manager, you must select the exact approach based strictly on your project's requirements, the risk profile, and the level of technical uncertainty you are facing. Let's take a closer look at the predictive model. The predictive approach, often called waterfall, follows a very specific path: feasibility, design, build, and so on. In this model, we try to lock in the scope, timeline, and budget as early as possible to create an integrated baseline. This relies heavily on meticulous upfront planning. Because we want certainty, any scope changes are strictly controlled through formal governance, usually a change control board or CCB. In a predictive project, the stakeholders don't get the product in pieces. They get a single, comprehensive final release at the very end. This works perfectly in certain environments. Let's see which ones. When is predictive the right choice? First, when you have stable requirements. If everyone knows exactly what needs to be built and it isn't likely to change, waterfall is highly efficient. Second, it is vital when there is a high cost of error. If you are building a nuclear power plant, you cannot iterate your way to a safe foundation. You have to get it right the first time. We also see this in industries with heavy regulatory constraints, where the government demands rigid documentation and strict phase gating. Finally, it works best when there is high technical familiarity. If your team has built this exact type of structure 100 times before, uncertainty is low. But what if the requirements are constantly changing? That's where adaptive comes in. In an adaptive or agile approach, we don't try to know everything at the start. Instead, the scope is progressively elaborated. We discover what we need through continuous stakeholder feedback. Work happens in short, time-boxed iterations, usually between 1 and 4 weeks. The focus here is on the frequent delivery of usable increments. Instead of waiting a year for a final release, the stakeholder sees progress every few weeks. This model actively welcomes and harnesses changing requirements to maximize value, even late in the development cycle. This shift in thinking also changes how we manage our core project constraints. To understand the difference between predictive and adaptive, look at the inverted triangle. In a predictive model, the scope is fixed. We must deliver X, Y, and Z. This means if things go wrong, the budget and schedule have to be variable, often leading to delays and overruns. In the adaptive model, we flip this. Budget and schedule, our time boxes, are fixed. We have 4 weeks and 10 people. To stay within those limits, the scope becomes variable. The team delivers the most valuable features first, and if time runs out, the less important features are moved to the next iteration. This ensures we never break our constraints while still maximizing business value. But what if you need both? You use hybrid. The hybrid approach is the best of both worlds. It combines the structured predictability of waterfall with the flexibility of agile. This is the gold standard for modern, complex projects. For example, you might use a predictive approach for your predictable operational work streams, like legal and procurement, while using an adaptive approach for the highly uncertain parts of the project, like software innovation. It is a highly customizable framework built strictly on your organization's culture and the specific situational demands of your project. Let's look at how we actually structure these hybrid deliveries. Hybrid delivery can take 3 main forms. First, sequential hybrid. This is where you use adaptive development for design or tech, which then leads seamlessly into a predictive rollout, like manufacturing. Second, simultaneous hybrid. Here, you have a predictive core, like building a physical device, while concurrently running adaptive sprints for the software inside that device. Finally, there is the pain point hybrid. This is when you take a traditional predictive project and insert minor adaptive techniques, like daily stand-ups, to solve specific team bottlenecks. This is a practical way to increase agility without changing your entire organization. Let's see this in action with a real-world example. Imagine you are building a state-of-the-art smart hospital. This is a classic hybrid scenario. On one side, you have the predictive stream, concrete, steel framing, and HVAC. You cannot iterate a steel beam. It requires definitive upfront planning and rigid gating because changes are exceptionally costly. On the other side, you have the adaptive stream, the user interface for the smart tablets and patient rooms. This requires continuous end-user feedback and rapid iteration to get the user experience right. The result? You successfully integrate the rigid physical structural constraints with highly flexible, user-driven digital systems. This is the kind of decision-making you need for the PMP exam. When you are answering exam questions, you need the decision mindset. If the project condition is high uncertainty or fast market change, think adaptive. Your goal is to deliver value and learn. If the requirements are crystal clear and there is a high cost of error, think predictive. Your goal is certainty and control. For everything else, think hybrid. The PMP tests your ability to intelligently match the framework to the real-world environment. Never lock in an approach until you have comprehensively assessed the risk profile and stakeholder requirements. And whatever you do, don't fall for the common traps. Watch out for these 4 traps. Trap 1. Don't forcefully apply a rigid predictive approach when requirements are described as vague or evolving. Trap 2. If you pick an adaptive approach as the answer, Make sure the scenario includes active, continuous stakeholder involvement. Without the stakeholder, it's not agile. Trap 3. Don't assume one approach is better or more modern. The correct answer is always about contextual alignment, not popularity. And trap 4. Never skip phase gates or governance just because the team says they are agile. Agile still requires oversight. Let's wrap it all up. To summarize our journey, the life cycle is your structure. It is the container for everything you do. Phase gates are your control mechanism. Use them relentlessly to validate strategic alignment and make those critical go/no-go decisions. Remember that predictive, adaptive, and hybrid models are simply varied tools in your belt. Your job is to select the right one for the specific project context. Finally, for the exam, master the inverse relationships between uncertainty and the cost of change. If you can do that, you'll be well on your way to mastering the PMP and delivering successful projects in the real world.